finding probabilities using normal distributions of application problems. So first, try these two problems, just looking over what we did in the last class, finding probabilities of a normal distribution just when we're given the probability statement, the mean, and the standard deviation. So pause the video and then check your answers when you're ready. So in the problems that we're given, we have a mean of 22 and a standard deviation of 3.5. Right, so we have a mean of 22 and our standard deviation is 3.5. And now we're going to need to standardize these scores, right, using our z-score formula, which is our data value minus the mean divided by the standard deviation. Right, so with the first problem, if I wanted to sketch the curve for this real quick, we know that our mean is 22. With the standard deviation of 3.5, 21.5 is going to be right here near the mean. Right, and we want x is greater than 21.5, so we want to shade to the right. So to standardize this, we have z is greater than 21.5 minus 22, all divided by 3.5. So our z-score is negative 0.14. So to find this probability, we can just go to the calculator, enter our values in, normal CDF. Since it's greater than, we want negative 0.14, comma 10,000, and that gives us 0.5557. Over here on warm-up number 2, if I sketch the normal curve quickly again, the mean is still 22, and we're looking between the z-scores of 18.75 and 21.5 again. It's 21.5. Right, so we're looking at this area, or this probability. So I need to standardize these. So I have 18.75 minus 22 divided by 3.5, and 21.5 minus 22 divided by 3.5. Alright, so there's my new probability where I'm standardizing my z-scores, or standardizing my data values into z-scores. So I have the z-scores negative 0.93 and negative 0.14. So we're looking between negative 9.3 and negative 0.14. So on the calculator, we would enter normal CDF negative 0.93, comma negative 0.14, and when we do that, we end up with 0.2681. Alright, so we have our example now, looking at the normal distribution with an application problem. So these first three examples are going to deal with the weight of adult male beagles. Okay? So the weights of male beagles are normally distributed. They have a mean of 25 pounds and a standard deviation of 3 pounds. So we have a mean of 25 pounds and a standard deviation of 3 pounds. We want to find the probability that the beagle's weight is less than 23 pounds. So we want the probability that x is less than 23. So in order to find this probability, we just need to standardize the data value. So I take the data value minus the mean divided by the standard deviation. So I'm looking for the probability that z is less than negative 0.67. And this probability equals 0.2514 after using the calculator and entering normal CDF. negative 10,000, comma, negative 0.67. Since we're looking at less than negative 0.67, we went from negative 10,000 to negative 0.67. Right? If it still helps you to sketch the normal curve, you can go ahead and do that, but it's not going to be a requirement from now on. All right, going on to the next example. We are still dealing with the beagles, where they have a mean of 25 pounds and a standard deviation of 3 pounds. So in this case, we want the probability that the weight is between 24.5 and 25 pounds. So we have to standardize both of these values. So we have 24.5 minus 25 divided by 3, and we have 25 minus 25 divided by 3. Alright, so once I standardize those values, we have z-scores of negative 0.17 and 0. So on the calculator, I would enter normal CDF negative 0.17, comma 0, and this comes out to be 0.0675. So that's a very narrow range of values, right? We're only looking at a range of a half a pound. So there's only about 6.75% chance that a randomly selected beagle would weigh in between those amounts. And now on to part C. We are looking at the probability that a beagle's weight is more than 30 pounds, so the probability that X is greater than 30. Right, we standardize this doing 30 minus 25 divided by 3. Right, our data value minus the mean divided by the standard deviation. Now we find the z-score we're looking at is 1.67. We have greater than, so if I was using the calculator, I would have normal CDF 1.67, comma 10,000, and this comes out to 0.0475. Now we want to look at these three probabilities that you have on your paper and identify if any of them are unusual. Right, so a quick recap. Part A, we found the probability was 0.2514. In Part B, your probability is 0.0675. And in Part C, your probability is 0.0475. Right? Now we consider unusual events. Unusual events have less than 5% chance of occurring. So 5% means less than 0.05. Right? So looking at our events in A, B, and C, the only one that is unusual is part C. Right? So it would be unusual to have an adult male beagle greater than 30 pounds. Right, so next, try these three practice problems dealing with a survey asking adults how long they spend on a computer each week. So pause the video, try the problems, and then check your answers. All right, so reading through this problem, we find that we have a mean of 7 hours and a standard deviation of 1 hour. So we have a mean of 7 hours and a standard deviation of 1 hour. So in part A, the probability that the number of hours spent on the computer by the participant is less than 5 hours per week. So we want to find the probability that X is less than 5. And we standardize that value. So we take 5 minus 7, all divided by 1. Well, that's just the probability that Z is less than negative 2. So we have less than, so we enter in the calculator normal CDF, negative 10,000, comma negative 2, and we find that this comes out to 0.0228. and we just found out that, or we just looked at unusual probabilities. This is less than 0.05, so we would consider it unusual if an adult only spends less than 5 hours per week on a computer. In part B, we are finding the probability that the number of hours spent on the computer by the participant was between 5.5 and 9.5 hours. Alright, so we have to standardize both of these values. So 5.5 minus 7 divided by 1, and 9.5 minus 7 divided by 1. Alright, so our z-scores for this problem end up being negative 1.5 and 2.5. So using the calculator, we can enter normal, CDF, negative 1.5, comma 2.5. This comes out to be 0.9270. So it's very likely that a randomly selected person would use the computer between 5.5 and 9.5 hours per week. Right. And finally, the last problem, we want to find the probability that the number of hours spent on the computer by the participant is more than 10 hours per week. Right. So we're finding the probability that x is greater than 10. Now we go to standardize this probability. We have 10 minus 7 divided by 1. So this is the probability that z is greater than 3. And just from what we know about the normal distribution, looking greater than 3 standard deviations above the mean, not a lot of data values take place there. So we should expect this to be a very small probability. On the calculator, we'll want to enter 3 comma 10,000. And this equals 0.0013. Right, so that's a 0.13% chance. Right, much less than 5%. So this is a very unusual event. Okay, so tomorrow we'll take a look at some other applications with the normal distribution. It really applies to a whole lot of different situations, and we'll see if we can kind of speed up these calculations a bit.